All right, so if you don't know what pyridine is, that's the first thing to figure out. It is a weak base. Um, I'm going to look up the KB of it and write that down. If I wasn't sure, I'd have to find out what it is. I could look around and then figure out if I found a Ka or a Kb. I can go from there. But because I found a Kb for it, I can treat this as a weak base. I don't really even need to know the formula. I can just go from there. Writing the equation is the hardest part usually for a weak base problem. The base gets combined with water to make the base plus hydrogen and OH minus. I'm plugging in all my numbers. I don't care about the numbers for hydrogen or for water. So I have the 0.05 for the base, 0 for the ions, minus and plus X. The Kb is the ions on top, original base on the bottom. Remember, water is left off because it's a pure liquid. All right, my Kb, my X is 0.05 minus X. I'm going to assume X is small, which tells me that 0.05 minus X is about the same as 0.05 by itself. There we go. All right, so now I need to cross multiply to get X squared by itself. And then the square root to get X. There we go. All right, anytime I assume X is small, I should check and make sure that it actually is. So that would be X over the original base concentration. And I want it to be less than 5%. You can see it's 0.018%, so that's great. From here, the easiest thing I can figure out is the pOH by doing minus the log of X, which is my OH minus concentration. Looking back at the original problem, they asked me for pH, so I can do that by subtracting 14 minus the pOH. And notice it is a little above 7, which it should be since it's a weak base.